So folks, this is homework problem 3 for week 3 of building construction, and I'll forewarn you that you're going to want to eat your Wheaties before you attempt this problem. There's nothing here that is conceptually that difficult, but it is somewhat computationally intense, and it does require some mathematical parlor tricks. But if you keep those two things in mind, it's not too bad to deal with. So let's think about what we know about this problem. There's some kind of fundamental laws of statics that you can apply, and one of those fundamental laws is that the sum of all the forces in the x direction must add to 0, right? For something to be in static equilibrium, it has to be in translational equilibrium, which means that all of the forces have to cancel out. And the same rule applies in the vertical direction. The sum of all the forces in the y direction must also be 0. So let's analyze forces that are at work here. We have the 600-pound weight that is pulling downward, which is creating tension in these two wire ropes. Well, that means that this wire rope, if we think about this dot here as being the center of our free body diagram, this wire rope is developing a horizontal component to the right. This wire rope is developing a horizontal component to the left. And I'll label these. I'm going to call this one A1 for adjacent side 1, and I'm going to call this A2 for adjacent side 2. And adjacent refers to the location relative to these angles that are given. Well, what do we know about A1 and A2? Well, A1 and A2 have to be exactly equal and opposite. So negative A1 has to equal A2. Or if we want to think about them just purely in terms of magnitude, if I put the absolute value brackets around them, the absolute value of A1 must equal the absolute value of A2. And these wire ropes also have some vertical component of tension, and I'm going to call this the O side for opposite. So opposite the angle, that's O2, and we're going to call this left side will be the side 1 of this thing. We'll call this O1, and this really is, I drew that too long. Well, what do we know about O1 and O2? Well, O1 plus O2 must completely cancel out the 600-pound weight that's pulling down on this. Now, with that given information, we can start cranking on some trigonometric identities. So let's just think about what we know. Let's use the cosine and sine functions to relate some lengths. Oh, one other thing we're going to need to do that. I'm going to call the tension in the wire rope T1 in wire rope 1 and T2 in wire rope 2. So the sine of 45 degrees equals opposite over hypotenuse, right? So toa, opposite over hypotenuse equals opposite 1 over tension 1. The cosine of 45 degrees equals adjacent over hypotenuse. So adjacent 1 over tension 1. The sine of 30 degrees equals opposite 2 over tension 2. And the cosine of 30 degrees equals adjacent 2 over tension 2. Those are all just basic trigonometric properties of this vector set. Now, there are a couple of other things we know, though. We know that A1 and A2 are equivalent, which means that anywhere that I see A2, I can strike it and in its place write A1. And this is kind of one of the mathematical parlor tricks. If you're dealing with two variables, if you can relate them to each other and then express the variables in relation to each other, you can get from 2 down to 1, which is a problem that you can solve. You can't solve a problem with two variables. What else do I know? Well, I know that O1 plus O2 must add to 600. So anywhere that I see O2, I'm going to strike O2, and I'm going to write 600 minus O1. And those are just identities that come from the nature of the problem. Now what I want to try and do is I want to relate tension 1 to tension 2. So if you look at the two formulas that probably make the most sense to relate are the cosine of 45 and the cosine of 30, because both of them contain A1, and both of them, they each contain T1 or T2 respectively. So my first step is going to be to get A1 by itself. So I'm going to say, what do? I multiply both sides by T1. T1 times the cosine of 45 equals A1. And I'm going to say, if I come down here and look at this one, A1 equals T2 times the cosine of 30. Well, if A1 is equal to both of these expressions, as we've shown here, let's just cut out the middleman and let's just set these two expressions equal to each other. So now you have T1 times the cosine of 45 equals T2 times the cosine of 30. Well, let's see how T2 relates to T1. Let's just get T1 by itself. So the tension in wire rope 1 is equal to the tension in wire rope 2 times the cosine of 30 divided by the cosine of 45. Well, remember that cosine of 30 and cosine of 45 are constants. You can look them up in a table, and that's going to be useful to us further on into the problem. Now we need to work on the vertical component of the problem. So if you look at the vertical component, those are going to have those opposite sides in it. And what we want to do is we want to get the O1 and O2s by themselves, although we've actually already eliminated O2 with this 600 minus 01. So how are we going to do it? We're going to multiply both sides by T1 for this first one. So sine of 45 times T1 equals 01. And same thing here, T2 times sine of 45 equals 600 minus 01. Well, now let's do some transforming so that we can set these two equal to each other and turn the crank. So what I'm going to do is I'm going to add 01 to both sides and subtract T2 times the sine of 45, so that this expression now starts to look like 01 equals 600 minus T2 sine of 45. Well, notice that we have two expressions that are now both equal to 01, which means we can set them equal to each other. So T1 sine of 45 equals 600 minus T2 sine of 45 degrees. And a slight correction there, though. This is T2 sine of 30 degrees, not sine of 45. Otherwise, everything would just cancel right out. So the question now becomes how to relate all of these three pieces. So now it just becomes a matter of some algebraic manipulation. We're just going to push this thing around. So T1 sine of 45, and then I'm going to add this T2 function, T2 sine of 30 equals 600. But you'll notice that up here I said that T1 was equal to T2 times cosine of 30 divided by cosine of 45. So I could take this T1 and get rid of it so that I just end up with T2. So let's try that. In place of T1 now I'm going to write T2 cosine of 30 over cosine of 45 times sine of 45. This whole thing here, just replace this first term, plus T2 sine of 30 equals 600. So you'll notice that the place that I've gotten to now through some kind of clever parlor tricks is I have an equation that has only one variable in it now, which is T2. Everything else in this is constant, right? Cosine 30 is a constant. cosine 45, sine 45, sine 30. They're all constants, and 600 is a constant. Now we can take this a step further. If you think about sine and cosine, well, sine equals opposite over hypotenuse. Cosine equals adjacent over hypotenuse. And we're asking you to take the sine, the opposite over hypotenuse, and divide it by the adjacent over the hypotenuse. But remember that division is the same as multiplying by the reciprocal. So O over H times H over A is equivalent. And now we can just simply cross cancel the H's. And we get that the sine of 45 divided by the cosine of 45 is equivalent to the ratio of the opposite to the adjacent. Well, that's just simply the tangent of 45. So we could rewrite this as T2 cosine 30 times the tangent of 45 degrees plus T2 times the sine of 30 has to equal 600 pounds. But this can be further simplified because T2 appears twice, so let's factor it out. So T2 times cosine 30 times tangent of 45 plus sine of 30 equals 600. Now, I'm trying to get t by itself, so I'm going to take t alone, and I am going to divide the other side by that. So T2 equals 600 over all of this junk. Well, let's simplify some of this thing. Let's find out what the cosine of 30 is. So 30 cosine. It's about 0.866. Times the tangent of 45 degrees, which should be 1, which it is. Okay. Plus the sine of 30 degrees is 1/2. So the tension in wire rope 2 equals 600 over 1/2 plus 0.866, so 1.366. And if we punch that up, we get 439 pounds. And that's the tension in wire rope 2. Right here, 439 pounds. Now, the last part of this deals with figuring out what the tension in wire rope 1 is. Well, remember that the tension in wire rope 1 equals the tension in wire rope 2 times the ratio of the cosine of 30 to the cosine of 40. So let's just figure that out. T1 equals 439 pounds times cosine of 30, 0.866, divided by the cosine of 45, which is 0.707. So if you think about it, this is going to yield something greater than 439, which we would expect. All right, so let's run through that quickly. 0.866 divided by 0.707 times 439 pounds is about 538 pounds.